MBS is the industry leader in the complete design, detailing, costing, and drafting of metal buildings. You can enter the desired building dimensions and then it will design that structure based on your local building codes and customizable shape inventory. MBS will then provide the bill of materials and customized drawings for the shop and field. Tekla Structures is the most advanced structural 3D BIM software for the detailing and fabrication of structures of all types. The constructible 3D model allows you to see exactly how the fit-up of the final structure is going to come together so that you can virtually build parts, welds, bolts, and more, and then have automatic reporting of materials and shop or field drawings created from that 3D model. By bringing these two industry-leading softwares together, you're able to create more complex buildings more accurately in less time than ever before. The designed and detailed buildings from MBS are transferred to the Tekla Structures Workspace to allow you to create skewed walls, hip and valley framing, and more, without having to rely on 2D drawings alone to make sure that the buildings fit up as intended. The process begins in MBS. This sample structure is made up of a central main building with 4 lean-tos connecting on the sides. You can see these a little bit better in the elevation views. By separating this project into 4 separate buildings helps us to understand how we're going to input this data into MBS. The data for each building is entered in a straightforward manner. This example of the main part of our building includes the width and the height, our eave heights and roof slopes. You can also enter things like your column base elevations. In here we can define the base spacings, we can define rigid frame locations and types. You can also define things like openings, you can define your roof purlins, your wall girts, types, spaces, and then finally we can apply the loads using your local building codes. The lean-to sections of our building are set up in a similar fashion. Here under the shape section we can choose a lean-to type, enter the overall dimensions and heights, all the same type of information, again including things like openings. You do want to make sure when you're defining your lean-tos that 2 of them are going to project past. That way we're getting full roof information going all the way out to the corners, and then 2 of them would be kept a little bit short because in MBS we can't have building sections that are overlapping with each other. That's the type of work that will be taken care of in Tekla Structures once the overall building design is completed. If you have similar building sections like we do with our lean-tos, you can very easily copy an existing, simply give it a new name, and now we have a copy that we can begin with and simply make the relevant changes to that section. Once all these separate building sections are completed, they can be combined into a project. Those separate buildings can be grouped here in the project editor. The buildings can be located using the drag and drop building location editor simply by, again, drag and dropping those to different locations and then snapping them to one another. In the case of building sections that are similar, it is possible to go ahead and rotate those if you need to change their position. Again, you cannot have building sections that are overlapping, and then they can be snapped in place. Once the combined buildings are designed and detailed, we're ready to import them into Tekla Structures. Just make sure that you have a Tekla Structures model open in the background, and then we can run the slide rule utility, which will go ahead and take all of the model objects that have been designed and detailed in MBS and import them into Tekla Structures. This is going to include things like all of your custom profiles and shapes for your girts and purlins. It's going to import all of the plates, welds, bolts, and sheeting. And after just a few moments, you'll have a constructible model in Tekla for you to finish the work on this building. Once the import process is complete, we can go ahead and close the MBS project. And here we can see that those building sections have been imported into the Tekla Structures workspace. Right away you can see that all of the sheeting has been brought in, but also all the structural members underneath. So the colors that we're seeing here are based off of a Tekla property called class. And the idea with class is that different objects should have a different color so that you can quickly identify the differences between them and get a good idea of what's what. Now, if you wanted to get a more realistic picture of this, you can turn on the colors that were chosen in the MBS design by changing your object representation to an MBS setting, and this way it'll quickly colorize the model so that you're getting a more realistic idea of what that building design was supposed to be. Now for this example, I'm going to go ahead and load the standard Tekla colors back in because as I'm modeling, I want to be able to kind of easily show the differences between those different types of parts. Let me go ahead and filter out the sheeting so that we can see that in a little bit more detail. You can go ahead and build filters for anything really based on things like the name or the color or the material grade. So I'm just filtering things based on the name sheet. If I zoom in here a bit, we can see that the structural members have been brought in, as I mentioned, along with bolts and welds, connection material, flange braces, everything that was designed and detailed in the MBS project. Now you may also remember that the separate lean-to structures were brought in, one going all the way out to the outside edge and one stopping short. So here in Tekla Structures is where we're going to finish the framing to create that hip condition. So to create the hip beam and column, what we did was designed it in MBS and then imported that again, just like the other building sections. However, we could have simply made it ourselves using the native Tekla tools, like activating the column command. And as you can see here, we have the entire AISC catalog already preloaded for you. If you're dealing with something like built-up members, we do have tools available for that type of material as well. But now that we have this beam and column inserted, we're going to go ahead and just select them, and we're going to move them into position. Going to choose one of the corners that we want to apply this. And then we're going to use a rotate command to turn this into the correct position. And as you can see, I've already got that value filled in. Once the member is in, we're going to go ahead and make some final adjustments and pull that whole column and beam back away from the edge of the building a little bit. And now we can start to address those extending purlins by using a command called split. Now split allows you to literally select a member and then choose where you want it to be split or where you want it to be broken. So in this case, we're just going one by one and we're selecting it based on some construction lines that we'd laid out. And then those members can go ahead and be deleted. For members that you need to extend, there's actually a command in the application and component catalog. There's several extend commands. We're going to be looking at one called extend beams to vertical plane. And this allows you to pick 2 points and it will literally extend those members out to that plane that you've created based on those 2 picked points. For other members, there is a tool called direct modification, and direct modification is our push and pull, drag and drop sort of modification where you can literally grab the end handle of a member and just stretch it out to the desired length. For this member, I'm going to go ahead and do a copy command. That way we do get the bypass or the overlap there at the column. And then the new piece we're going to grab and use the same direct modification to extend out to the corner. Now once we've got this corner situation set up, we could go ahead and start creating connections using some of the basic modeling tools. We can use plates, we can use bolts, we can use welds. But the application and component catalog contains a lot of standard connections that you're going to be able to use to connect your framing together. This is an example of a shear tab, and as you can see, you can adjust plate sizes, bolt locations, and all kinds of information. You can also save away standardized connections once you get what you are looking for and apply those between your members. And as you can see, that's going to add things like plates, it's going to add bolt holes, it's going to add welds, and literally build those connections for you so that you're not having to create those manually, even though that is possible. Now when you do need to create something manually, we're going to have an example here of creating the support of the hip beam up to the corner here. And the first thing we're doing is we're changing that work plane. We're making sure that the work plane of any members matches the hip beam, and you can see that based on that coordination icon there. Then we can activate the beam tool and we can start to model in supporting members. In this case, I'm creating a channel. And then just like before, we can open up the applications and components catalog and we can search for a connection like a shear tab and use that between the supporting members. Again, save away these types of connections so that you can quickly load them and apply them in the model. Now to connect the hip beam up to that channel, I'm going to use a different connection, just an end plate. And you can search based on the name of a component or the number if you know what it is. Again, going to load some settings here, and then go ahead and apply that between the two members. And that will create my welds, my bolts, and all connection material. So when you have a situation that's a little more complicated and requires you to manually make connection parts, the process pretty much starts the same. You want to make sure your work plane is set up correctly, in this case along the hip beam again, and then you can go to your Steel tab, activate your plate tool, and set up your size and position. To create a plate, you simply pick the corners of the plate, and because we changed our work plane, the plate's going to show up aligned with our hip beam. So you can go ahead and type in those dimensions, but I do want to show you how you can use that direct modification we showed earlier. Here you can click on an edge and then type in a dimension and automatically upsize that edge of the plate. So very quickly being able to resize those objects. Now I want to go ahead and create a folded plate between this tab and the purlin. So I'm going to do this in sections. First thing I'm going to do is create the edge or the side of that folded plate that connects against this tab. Once this is done, I can go ahead and start creating the plates on the purlins. Again, first thing we want to do is change our work plane. So if we align the work plane with the face of the purlin, when I go to create my plates will also be aligned with the purlin. So under the plate creation dropdown, there's this create cylindrical bent plate command. And basically what you do is you pick the two halves, and then this tool will extend and combine them to create that folded plate. So now we're going to weld it down. I'm just simply loading a weld tool, choosing a 3/16 both side fillet, picking between the rafter and the tab plate. And we can also create bolt groups, but again, going to set the work plane because we want to make sure those bolts are going straight into these two plates. So now when I go to create these bolts, they'll be aligned with that face. I'm going to pick 2 points to indicate their run, and then we can go ahead and adjust things like their grade, their diameter, and their spacings. All of these grades are included out of the box, and they are of course customizable to add additional bolts if you need them. So once you've created all of these objects to connect these parts together, you can save these away inside of the component catalog as a custom component. All you have to do is give it a name. I'll call this purlin at hip. Say next, and then follow the steps. Select the objects that make up the component, select the part that you're connecting to, and finally select the parts being connected. This will create a new joint with a cone. And if I want to reapply this very quickly in similar situations, I can find it in the catalog and then simply pick that same order to create that joint. This allows you to create similar framing conditions very, very quickly in the Tekla model by using these custom components. Once the framing and the connections are all complete, we're going to go back and start working on the sheeting. So I'm going to turn off that filter to bring all the sheeting back into the view. And we're going to work on trimming back some of this excess and then also creating new parts to fill in the gap. First thing I'm going to do is lay in a construction line along that hip. This just helps me see a little bit better what I'm trying to do. And then we're going to set our work plane again to the roof slope this time. This way I'm working in the same plane as the sheeting. One thing I'm going to do a little bit different here is I'm actually going to create a view in that plane. And this allows me to look at the roof as if it were flat, looking at these sheets as if they were flat. So it's a little bit easier to work on them this way. So I'm going to take this construction line and I'm going to copy it 4.5 inches over, kind of providing a little bit of a gap, a little bit of a setback for where I want to trim these. And then we're going to go to our Edit tab and we're going to use the split command, just like we did for the purlins. Now in this example, I'm going to cut them to their longest point, right? So we're square cutting these off, basically the shipping lengths for these sheets. But if we wanted to, we could use a line cut or we could use a fitting to cut these at an angle in more of a final cut or a field cut length It really comes down to how you want to present the model and what kind of data you're trying to generate out of here. So I'm going to split just a couple more pieces here, and then once all the parts are split or broken at those points, just like the purlins before, we can go ahead and just delete the excess that's no longer required. So now that we've got those trimmed back, we can model in new parts. Now we could use the beam tool and load a sheeting profile and manually draw those in. But I want to show you a tool here that allows you to create these kind of broad panel spaces very quickly. It's called the Floor Layout tool, and you can find it in the component catalog. This tool allows you to load in a type of profile, in this case a sheeting profile. You can change its name, you can set up its material grade and more, and then you simply sketch over the area that you're trying to cover, and it will calculate how many panels are required with their overlaps and then create them very, very quickly over that space. Now, as you can see, the settings I'm using right now are again square cutting or giving the rough lengths of these sheets. But this tool does have the option inside, if you go to the Advanced tab, to change this up to give you again more of that field cut or finish cut look. Again, comes down to what you're trying to represent in the model space. I'm going to go ahead and change that back to their square cut just so everything matches, and then I want to show you something else that's neat about this tool. We've looked at direct modification already, where we can stretch members and change plate sizes, but there are some components that actually work with direct modification like this one, where you can stretch the edge of that border and it will go ahead and increase the number of panels or decrease the number of panels automatically. So that way you can very quickly edit and create all the sheeting layouts that you need, not just on the roof, but even vertical wall panels and floors. Once the model is complete, we can start making drawings. I'm going to flip to a plan view here and then right-click in the background and choose the Create General Arrangement Drawing setting. There are a lot of MBS-related drawing settings downloadable from our Tekla warehouse, so I'm going to choose the Roof Sheeting option, and when I click Create, it'll take this view and place it on a sheet of paper, along with title blocks, tables, and all of this is fully customizable to meet your needs. If I wanted to create another type of drawing, for example a rigid frame elevation, we can go ahead and open up that model view, right-click in the background and choose Create General Arrangement Drawing. Make sure that the appropriate drawing settings are being applied, in this case rigid frame settings, and then click Create. It's going to take this view and place it on a sheet of paper for us, and here we can go through and start adding dimensions and marks if we wish. There is a tool, however, that can help. If we run this rigid frame dimensioning tool, what this is going to do is scan through the drawing and find the appropriate dimensions and marks that would fit for this style of sheet. Of course, after it's done, you can still add additional markups if you choose. If you want to create shop details, we have drawing settings for columns, beams, purlins, and all kinds of other parts that you can customize. If you want to create single part details, there are specialized settings for folded plate versus normal plate, and again all kinds of other objects in the Tekla model, fully customizable. All of the drawings that are created are added to the document manager. Here you can double click to open those drawings, and as you can see, sections are cut, dimensions are added, bills of materials are filled out. All of this drawing automation is possible inside of Tekla Structures. To extract even more data from the Tekla Structures model, there are dozens of included reports. You can also create your own using a tool called the Template Editor, or you can download additional reports from the Tekla warehouse like this punch list. A popular tool is called the Organizer that scans through the Tekla model and literally organizes it into groups. There's a specialized MBS group available that you can see breaks it into different object types, and when you select one of these object types, you get a spreadsheet style layout of the information in that group. So whether you're doing columns or purlins or sheeting, you can quickly access this information. And then you can export this very quickly to an Excel spreadsheet to create your shipping lists. Thank you for joining us for this video and learning more about the integration of these two industry leaders. With the exclusive link between MBS and Tekla Structures, you can create your metal building projects easier, more accurately, and faster than ever before.